the first 2 weeks of this unit is all Algebra 1 review from when you were a freshman. Okay? We're going to set up 2 equations, solve it. That's where you remember graphing the lines and shading, where the shaded regions overlap. That's what we're doing. So we got to take about 2 weeks to review some Algebra 1 topics, and then at the end of the unit, I'll show you how to use those for some pre-calculus topics. That's the goal. All right, so for the first couple weeks, if it's like, oh, this is easy, it should be. It should be easy because you've seen it already a couple times already in your high school career. All right, let's get going. You guys remember your numbers, or do we have to re-sign numbers? Who's got the highest one? 13. Okay. Everyone's good? Okay. Because to make this go quick today, so you guys have a lot of time on your own, I'm just going to call on numbers. All right, here we go. I'll let you guys read through the first question there about the different ships and where's the spotlight going to be. And we'll review some Algebra 1 stuff from freshman year. All right, help me out here before I start calling on people here. Ship A has what equation? Y equals 2x, and ship B? X plus 5. And I'm basically looking, where do they intersect? All right, because that's where the lifeboat's going to be. So back in 9th grade, you guys probably had 2 main ways of solving 2 equations at a time. One was called the substitution method, and the other was called the elimination method. You're going to do both here today. What I'm going to ask you guys is probably what's the best method to use right now if they're both equal to y? Well, you're going to have to show work, though. You can't. I know you'll probably want to. Substitution. Since they're both equal to y, I can take one of them and substitute it in for y in the other equation. Pretty basic review right there. So what's my new equation going to look like? Rewrite my new equation for me. Let's start this off. Number 1. There you go. X plus 5 equals 2x, and nothing too difficult for this first one. X equals 5. The only thing you got to worry about, you're looking for a coordinate. What's the coordinate? All coordinates come in x comma y form. So how can I find what the y coordinate is now? Doesn't matter which one I plug it into. Nope. All right, does not matter which one I plug it in for. So the y coordinate is going to be 10. And in this unit in particular, I'm a big believer in you guys should be writing something at the end that says the lifeboat's at 5:10. Instead of leaving your work there and having me trying to decipher what your work is, just write a little conclusion. So the lifeboat is, so it doesn't have to be word for word just like this, but the lifeboat is at 5:10. Something like that. All right, so I don't have to follow your work. Okay, no issues there? Pretty easy, right? How many of you took economics first semester? First semester, did they talk about a break-even point? No? Yes? Okay. Well, on the second problem, it's fine. No big deal. The second problem here, we're going to sell canoes. All right? It takes so much to make a canoe, and then I'm going to sell it for so much. And I want to know what's my break-even point. So the first thing, I just got to get a quick definition down, a break-even point. All right. That'll be the number of canoes I sell where my cost, however much it takes to make them, is going to be the same amount as the money I bring in, which I'm going to call revenue. So when are those two equal? How many canoes is it going to take to make for when the cost of making them and the cost of selling them are equal to each other? All right, so I'll let you guys read through. There's a whole bunch of money thrown out there. All right. See if you can figure out how much it's going to take to make a canoe, and then see if you can find out how much it's going to take to sell a canoe. Let's talk cost first. How much does it take to make a canoe? Okay, 20 bucks, but you also have this fixed cost of 18,000, which basically means you sell one canoe, you still have to pay 18,000. You sell 100 canoes, you still have to pay 18,000. So it's a little bit more than 20 bucks a canoe. It's 20 bucks a canoe plus that 18,000. Everyone see that? That 18,000 is no matter how many you sell. And it looks like we're going to let X equal the number of canoes. So cost, what do you got for me if you're going to write your own cost? 18,000 plus 20 bucks a canoe, 20X. Yep. So that's how much it's going to cost to make a canoe. How much you selling them for? 80 bucks. Also X, so it's going to be equal to 80X. Everyone all right there? Cost, 18 grand plus 20 a canoe, and then revenue, $18. And then here you go. Just solve it. No two equations here at all. Go ahead, solve for X. Two. How many canoes to break even when you're ready? $300 canoes, yep. So just so I know we got this concept down, you make 300 canoes, how much you going to make? Nothing. 299. You're going to lose money. 301. Now you start making some profit. All right, that's what that means. 300, nothing on each side. Any more than 300, you're going to start making some money. Everyone all good with the canoes? Perfect. Look how quick this is going. All right, this is probably what you remember from freshman year right here. There's these type of problems. I'll let you read through toothpaste, toothbrushes, and cost of a bar of soap. So it looks like X is going to be toothbrush, cost of toothbrush. Y is going to be cost of a bar of soap. Anybody got their first equation for me? Would you actually should ask somebody instead? 8 in the house. Okay, ready here. So here, 2 toothbrushes, 1 bar of soap, 11 bucks. What do you got for me, Spence? Done. And then what about the other customer? Equation for the other customer. What do you got for me? Oh, Spencer, on fire. Go ahead, 8 again.
6x plus 5y equals 38.
Guys, you got any issues with this before we talk solving it? Okay, how do you solve it? Got to eliminate a variable. Can I eliminate any of them right away right now? Nope. So that means I'm going to have to use the elimination tactic, which means eliminate one of the variables by multiplying one of these equations by something. So I can get rid of the x's or the y's. Multiple answers here. You can multiply it by a bunch of things. You want to go, Matt? Go. That's what this is. This is what we're doing. Anytime you're solving 2 or more equations at the same time, it's called a system. So that's what we're doing. Did you mean a matrix? Well, that's what we're doing, a system right now. So okay. How are you going to get the y's or the x's out? Got to eliminate one of them. 10, little help. One way, multiply the top by -5 because that'll get rid of what variable? The y's. Or if I wanted to get rid of the x's, multiply the top one by, okay, your choice. Okay, I'll just go with Bella's first one, which was multiply it by -5. Fine with me. Distribute all the way through. Hey, all the way through. I see a lot of times kids forget to distribute on the other side of the equal sign. One job, get it done. All the way through. Okay, we just said the y's are gone. And what are we left with here? Negative 4x equals negative, what do you got there? 17? Okay, it's not going to come out to be a whole number, but we're dealing with money here, so it's okay. So x, when you get it, let me know. 10. $4.25. Yep. There's x. How you want to find y now? Here you go. 5. How do you want to find y? Either equation, either of your two originals. I always like to go back to the originals just in case you made a mistake. I wasn't asking your opinion, but sure, Pat. Yeah, I'll plug it in the top one. And then go ahead, solve for y. And how much for 4 bar of soap? Yep. Oh, nice. Thank you, sir. See you later. Have a good night. Okay, any issues? Coming back to you from 9th grade? 2 more and we're done. I got some chairs here now. That's the important part. It comes with a footstool. How many rocking chairs were sold? Okay, I need to know what are the 2 things here we're talking about? The 2 items we're trying to find. 10. What are my 2 items I'm trying to find here? And? Okay, so I got rocking chairs and Adirondack. Unlike the last problem, it doesn't say let x equal this and y equal this. You guys got to determine that on your own and show me what they equal. Class decision here. What do you want the rocking chairs to be? Okay, I would have thought R, but okay. X is your rocking chair. No big deal. I'm assuming Y for Adirondack.
B. No, still B.
Make it whatever you want. I just got to know, though. Remember, these are called your let statements. I got to know what each variable means. All right, you guys got a lot of numbers flashing at you up there. 2 equations now. Got to involve x and y. 2 equations. 2. How many total chairs did they sell? You want to put that in the equation for me? I got 2 types of chairs, 48 total. Total. There you go. And guys, make it easier on yourself. Money stays with money. Okay? 265, 320, and that 13,930 should all be in the same equation now. Money stays with money. And the second equation using the money, 5, what do you got for me? Second equation using the money. Yep. Whatever you guys called the rocking chair, 265 has to go with it. Whatever you guys called the Adirondack, 320 has to go with that. We're on our way. What do you want to multiply by, kids, to eliminate a variable? I forgot to put x up there.
multiply by negative 265. In my opinion. When we do it by
That's fine. Okay, hold on. That's fine. All right. If you look at what the question's asking, it's looking for how many rocking chairs. So I kind of want to just keep X where it is. Now, look, if you solve for Adirondack, who cares? Plug it back in and find the rocking chair. That's not a big deal. All right, not a big deal. So if I want to try to eliminate Y, what do I have to multiply by? Negative 320. Yep. Now, again, you multiply by negative 265. Nothing's wrong with that. You're just going to find the Adirondack first and plug it back in to find the rocking. Go ahead, solve it. Two. How many rocking chairs am I rocking with? Whew. No problems. One more. You guys can read about the number of 1- and 2-bedroom condos. Okay. Variable time. Looks like I got, what do you want for the 1-bedroom? X, good idea. I'll go Y, 2-bedroom. Okay, where are your two equations coming from? If you read through, I gotta need two equations. Money stays with money, but you don't have to go that way first. 5, you're up with the first equation. 50 total units. There we go. Now the money here, I'll take care of the money. I won't call it anybody here. Notice how it says 150,000. I wrote it like that. You can, if you want to add in the 3 zeros, you can, but you can also just leave it 150. We know it's all in thousands, so instead of dealing with large numbers, because this one right here, you're going to have to add 3 more zeros onto it as well. So instead of dealing with the large numbers, you can just leave it like that. So how much for the 1-bedroom? 100 and, so you can leave it 120x instead of adding on the 3 zeros. And then 150y equals 7,050. I'll let you guys go ahead and let me know at the end here, about 2 minutes. Okay, take your time. If you're not ready yet, that's fine. 6, whenever you're ready. How many 1 and 2 bedrooms am I going to end up with? Yep. There you go. That's how it's going to go, guys, right there. I'm done. Which means you're done for the day. You don't have to move on and try examples. As soon as you come in tomorrow, you're working on your own on the next 3 pages. Okay, I can answer questions. That's not a big deal. When you're done, you'll raise your hand. I'll check your answers. All right. No partners tomorrow. This first week here will be on your own. And that's it. Going to seem easy at first.